Hey everyone, my name is Brian, and today I'm going to talk to you guys about setting up an SQLite database and building SQL functions for that database in an Android application. This is part one of a two-part tutorial series on using a local database in your Android application. Okay, so this first part is going to be split up into two classes. One is going to be the database helper, which is going to be used to actually create the database by adding tables to it and managing, upgrading the database, and the other will be database control. Okay, so now just to save some time, I've gone ahead and defined some of the variables we're going to need and the constructor. Okay, so a database helper is a class that we're going to make. It's pretty lightweight, but it's basically going to extend, it's going to be a subclass of SQLite open helper as defined here. So go ahead and extend SQLite open helper and just make sure you don't add an extra L in there. It's just the one L they share for the two words. And you're going to need to import that library right here. Okay, great. So I'm just going to explain quickly these variables. The first one, database name, is a constant we're just going to use to actually define the name of our database. It's just better to store in variables in case you needed to use it later for upgrading the database. Database version, we're just going to set it to 1. This is the idea of a version is later on if you want to have different versions of your database, you can upgrade it to that. We're not going to really concern ourselves with upgrading in this tutorial, but just we need one for the initialization. As well, this is just a database create statement for one of the we're only going to really have one table in this tutorial. You could have multiple tables. There's definitely a better way of having these queries. You might want to have them in a file. Since we're only having one, I just made it as a string, and this is just going to be a simple inventory table. It'll have an ID, which will be the primary key, item type, which will basically be the name of the item, for example, like a book, and then quantity, and it's going to be, we've got the different types, the integer or text for the name and integer for the quantity. Okay, so now for the actual constructor, they actually, when you try and add a constructor up here, it'll suggest passing through the database name and the other thing, and the version through the actual constructor when you're calling it. But we want to pass it within this class itself. So our constructor is only going to take in context. So when another class is calling it, it only has to pass in the context. So actually, we're going to have to import that. Okay, so now that we've done that, we're going to have to call the superclass. That's all we're going to do in this constructor. We're just going to pass the context, the database name that we defined up above, a null, and the database version. Now, what this will do is it'll pass to the SQLite open helper, so it'll grab the database and create it for us. So it's kind of nice. We don't have to do that work. We're using kind of a lot of inherited methods in the background that we don't need to worry about. Okay, so now we can move on to actually implementing the unimplemented methods from SQLite open helper. Luckily, the only ones we have to implement is the onCreate and the onUpgrade. So onCreate is basically once the database has been created, this is where you want to execute your SQL create statements to create the tables in the database. So to do that, we're just going to call DB, which refers to the actual database itself, and exec SQL, and what we're going to pass to it is the database create. And that's it for that function right there. So that will actually call and execute this create statement, and it'll create the table in our database. Now for upgrading, we're just going to add some simple stuff. You can do a lot with this, but just for the purposes of this, we're going to execute a drop statement, which is basically going to wipe the table clean. So if you wanted to upgrade the database, you want to start fresh again, you want to wipe all the data off of the table. So this will take the inventory table and drop it, and then recall the create function and create a new database. Now there can be a lot more involved with if you want to change the versions. That's why there's passing in different versions. We're actually not going to get into this, but for the sake of fulfilling the inherited methods, we're going to add that code right there. Okay, so this is actually all we have to do for this SQL online SQLite Open Helper. So now we can move on. Okay, so now we're going to move on to the database control. And basically what this is going to do is basically control any of the SQL calls we actually want to make. So this is where we're going to define our SQL functions, and this will allow us to add, upgrade, and delete data from the database. Okay, so I went ahead and actually defined some variables and defined the method signatures for a lot of these so we can save some time. Okay, so first of all, I'll run through the variables. We have the row ID. This is just a string that will map to the name, the actual name of the column for the row ID. And the next one is the item type. This will match to the item type column name in the actual database table, and same with quantity. We need to do this, I'll explain later. We need to actually have a key value pair when we're actually passing values or upgrading values in the database. Also, this is the name of the database table. We're storing that as a variable as well. And we're also going to have context. We're going to have to import that. And a SQLiteDatabase object. So we're going to have to import that as well. And now also a database helper. So it's actually we're going to instantiate that to the object we had just created earlier, or the class rather. Okay, so now we have this constructor. It's very, very simple. Just going to take in context and pass that context to the context variable we have here. So for later when we're calling the database helper. Okay, and the next function we're going to implement is a open. So this will basically, when you want to open up the database for making calls, we'll call this function. So we're just going to actually have to have it throw an SQLite exception. So if there's a problem when you actually, when there's a problem with actually opening the database, we can know about it and we can handle any problems with that. Okay, so this is actually a pretty simple class. We're gonna, in here, set up the database helper, and it's going to be a new database helper, and pass context to it. And we're going to use the database helper to actually give us the database, have access to it. So it's going to do what is called a get writable database. And we actually want to return, since we're returning a database control, we're going to actually return this class itself. So you're going to go return this. Okay, good. Now close is a super simple function. You just have to actually call the database helper close function. This will basically close off the database. You never want to have, you always want to close the database after you're done making any of the calls or any of the SQL statements you needed for your application. So anytime you use it, you want to close it. Now we're going to move on. The basic things we're going to cover in this tutorial: we're going to add an item to the database, update an item, and be able to fetch all the items so you can display them and see the actual database, what's inside, and deleting an item. Now this fetch item by ID will be kind of actually a function that these other functions will utilize. In that I mean this fetch item by type will allow, or fetch item ID by type rather, will allow people to, or will allow someone to input the name of an object, and when they click add or update or delete, it'll take the name and search in the database and find the ID for that given row, so that we know what row we want to add to, or add if it doesn't already exist, or update if it does exist, or delete, etc. Okay, so add item is actually fairly lightweight. We're going to pass content values to it, so we have to set up content values. And as I said earlier, you need basically a key value, a list of key value pairs to pass to the database. Now this is going to throw a bunch of red flags for us because we haven't defined a lot of this. The content values, we're first of all going to have to import that, but we're going to actually have to create a content values function, and this will create our key value pair list. Now, this is a function we're going to have to define, so I'm going to actually jump down here to the create content values function that I've created. And this is going to take in the type or the name of the item and the quantity, and it's going to set up this key value pair list. So how we're going to do this is set up a new content values. And then we're going to go values.put key item type. So that's the actual key that referred to the name that's in the database for a given item. And the value we're going to pass is type. And we're going to do the same for quantity. So we're going to go values.put and then key quantity, and we're going to pass quantity to it. And we're going to return the values. Okay, so now that we've set up that create content values function, this, like I said, will create the key value list that we can pass the database. If you know any SQL, you know that you have to pass what ID you're referring to in the database and what value you want to pass to it. So that's kind of the same idea. It's just how it works with the SQLiteDatabase is you create a list of these key value pairs. Okay, so now that we have that function that creates the content values, now we can actually make a insert call into the database. So if we go database.insert, we can actually, it brings up this function, and this function acts almost like an SQL statement. You pass to it the arguments you would normally pass in an SQLite or an SQL statement, but it's kind of in a nice function format. So we're going to pass, you have to pass the table name. So after we've passed the database table, this null column hack we don't have to be worried about, so you're just going to pass null to that. And then we're actually going to pass the setup values that we created up top. So that's all we have to actually do, and this returns, the insert statement will actually return the row ID, so that way we can see where the, after we've done the insert statement, where we actually inserted it into the database. Okay, now we're going to move on to the update item. So let me just copy this actually, bring it down there, we'll call it update values, just to make sure so we don't mix it up. And this one also will pass type and quantity to the object. But instead, it's going to be a little more complicated, the insert statement. We're going to actually call the update function of the database, passing in, as before, the table name, the update values, so the key value pairs, the where clause. Now, any of you who know SQL, it's kind of like a conditional statement, so we want to update only the a given row at a given row ID, so that's why we passed ID into the update item function. So we're just going to do it like this, but it actually has to be passed in similar to how you would pass it in a database or in an SQL function. There's a where args and the where clause, so you can do it one of two ways. You can put the clause would be the key row ID, so what we've defined up here with underscore ID equals, and then the argument is the actual ID that we've defined here. But a way that a lot of people do it in a simpler way would be to actually just have the kind of the string set up here. So we'll do key underscore row ID, and then concatenation equals, and then another concatenation and ID, and then you just set the last argument to null. So it's kind of like passing it as a string as opposed to an actual separate argument. And then actually to finalize this out, we're gonna, is it greater than 0? And basically, the update function will return how many arguments it updated, because you can update multiple arguments at a time. So we want to make sure it's greater. It actually updated something, so that's how we check that. Why we check it's greater than 0. Okay, now we're gonna move on to fetch item by type. And what, as I said earlier, this function is going to allow us to do is, given a item name, we can search into the database and find the actual row ID for that item. So first of all, since we're actually grabbing data this time as opposed to adding or updating data, we have to grab data in a form of a cursor. This is how databases work for the SQLite database in Android. And what a cursor is basically, it's kind of like a file pointer. It points to the data, and it allows, kind of in its structure, and it allows you to access the data that's been returned from the database from the call. So to do that, we're gonna have to set up a cursor object. We'll call it db cursor. We're just gonna set up another variable along ID 0 just to store the ID later on. We're gonna have to actually import the cursor library. Okay, so next we're gonna have to actually initialize this cursor to the result of the database. So to do that, we're gonna go db cursor equals database dot query, and this function has quite a few arguments, most of which will actually be null. If any of you know, a select statement in SQL tends to have a having or a grouped by, a lot of different statements that we don't need in this particular instance. So this is true is actually just passing whether or not we want a distinct result. So for the distinct clause in SQL, we want only one result, so we're just going to put distinct there as true, and then we're going to pass the table name, and then we're going to pass an array of keys, or rather column names for the specific columns we want from this result. So we want the key row ID, only the key row ID in this situation. There you go. But you have to actually pass it as an array because it takes an array. Oops, not all caps. So it takes it as an array, so you have to pass it as a string array, but only of one element in this case. If you wanted more, say you wanted the quantity as well, you could add the quantity to that. And then this is the where clause actually, so we're going to do where the key item type concatenation equals concatenation type. And now, just to ensure that it takes it in as a string, we're going to actually add a space and then the single quote, and also double quote, single quote, double quote here, just so it interprets it as a string that we're passing to it. And then for the rest of the arguments, oops, we gotta add concatenation there. For the rest of the arguments will be null, so just null. There will be 5 nulls after that. And just close off the function, or close off the call. Okay, good. So it's quite lengthy, but once we've done the query, that will return the database cursor. And we want to, the way it works is the cursor will grab the data, but it'll actually be pointing, it won't be pointing to the beginning of the data, so you have to actually move it back. So to move the cursor back, you just call dbCursor dot move to first. Okay, and then what we're going to do is, now that we're at the beginning, we're going to have that ID variable that we set up top. We're going to say ID equals dbCursor dot get long. So we want, because we want the result as a long value, and dbCursor dot get column index, and we're just going to give it the column name, so we wanted the key row ID. So it's quite simple. You can grab the data based on the row. It kind of gives it into a kind of a fairly readable structure. Now, one thing we have to consider is if the query returns nothing. So if there is in fact no result, we want to return an ID to them that indicates that nothing was found. So in this case, we'll just use an ID of -1. But in order to catch this, you can't actually check. It'll actually just throw an error or an SQLite exception when something like this occurs. So just go wrap all the code and go surround with try catch block. So it'll just give you a generic exception to catch all of them. So, but in this situation, we're just going to want to catch specifically the SQLite exception. So we'd already luckily imported that, so that is seen there. So we don't want to actually print the stack trace. What we want to do is we want to set the ID to -1. And then at the very end, we just want to return the ID. So any class or any function calling this function will receive either the ID of the updated object or a -1 indicating that no item was found. And then you're going to have to actually handle that outside of this call to determine and tell the user either the update failed or the add failed or the delete failed, and so on. Okay, so now that we've defined that, we can move on to the fetch all items. Now I've chosen to return it as a string. So I mean, you can return it as many different things. You can have it as an array of data, but just for the purposes, since we're only going to display it just in a simple text view, we'll have it as a string. So just set up a string called all data. All right, now we're gonna have to create another cursor like we did up top. Call it db cursor, and we're gonna have set up here, and then db cursor equals database.query, and like the other one where there's quite a few arguments we have to add to this one, but since we're not doing distinct, we want everything. We don't have to actually add the true like we did up top here. So we're just gonna add database table. Then we're going to add the column names, so we have to add a string array. So we're going to pass the key row ID, key item type, so or item name, and key quantity. Brackets there. Okay, good. So now that we know what columns we actually want, and all we have to pass after that is just nulls for the rest of them, because this is just a wide call. We want all the data we can. There's no condition on this. We want everything, so we're not specifying only a specific record. Set the rest of these to null. And semicolon. Okay, cool. Now that we've done that, we want to take these results and store and actually print them out in a kind of a readable fashion. So we're going to set up some variables first. We're going to call it, say, iRow equals db cursor dot get column index. Key row ID. This, by setting up these variables, it will just make it easier later on when we're doing a for loop through all of the objects in this cursor, so that we actually can just call, as opposed to having to call get column index every single time based on something. This way it saves us some time, or saves us some clutter rather. So key item type. and int I quantity. And key okay, cool. So this will always give us the index of the given row ID, the item type, and the quantity. Okay, so now we're going to make a for loop. So it's going to be for, and what we want to do is, just as you would initialize the counter back to 0, like we did above, we're going to move to first. So that's our starting point, the very first, or the beginning of the cursor. And then next, we're gonna have a condition where it's not after last. So we're not after the last object. We're until we hit the end of the list, or the end of the cursor rather. And db cursor dot move to next. So every loop it will move to the next item in the cursor. Okay, so now that we've set that up, we're going to basically keep appending to the string and creating this kind of table-like string that we can use to output later. So we'll do all data equals all data plus space db cursor dot get string I row. So this will get the row ID as a string, and then just add a tab in there, separate it up. Remember to concatenate. I seem to be forgetting to concatenate. I might want to add a space after that. And then db cursor dot get string, and we're at the item type we want. And since the item name might be kind of long, let's do a bunch of tabs. I mean, this is kind of a on-the-go setup, but if you want to really display it nicely, there are other ways of doing this. This is just for kind of a simple output. And get string I quantity is what I'm going to pass. There you go, and just add a new line so that you don't have all the records on the same line, and it'll look a lot more like a table. Okay, cool. So now we've created this string. Now, like above, we've got to consider if the query fails, say if there's nothing in that table. So we're going to have to, like we did before, surround with a try-catch block. And we're not going to print a stack trace, but rather we're going to set the all data string to empty. Or actually, we don't even have to do anything because we've already set it to empty up top, but just so you see it again, you can set it to empty, and then all data. I'm just going to return that back. Okay, cool. So now we have a string that is displayed like a table for all the data in our database. Okay, now the easiest and final function of this class is the delete item. Okay, so the delete item, all it takes is the ID of the row we want to delete. So, and all it actually does is return the result. We call the delete function of the database and return whether or not any rows were actually in fact deleted. So we're going to call database delete, and we're going to pass the table name. So again, that variable we defined up top, and then key row ID, where the row ID equals ID, and pass null for the last argument, and check if it's greater than 0. There you go. So that looks like everything for this. Now we have a way of setting up the database, SQL functions to manage the data, and add, delete, and view all the data. So now we can move on to actually interfacing with the user, allowing them to input data and grab data. Oddly enough, it'll actually be potentially more code and a little more complicated to do so, but we'll see that in the next tutorial that's about to come up. So